railway engineer, because there will be ECRL in the East Coast punya. Sayang, there will be no high-speed rail from KL to Singapore. Otherwise, if there is ni, boleh lah pergi tengok Zahir kat Melaka, boleh pergi tengok lah Zahir kat Johor, because we have this high-speed rail. Saya tak boleh duduk lama-lama atas kereta kan. Right, now, so this Bobo, I said now is Bobo is working at this steam power plant Manjung there. Manjung ni, dekat lain ni, kat overseas ni. Okay, there are TV diagram, there are PV diagram, there are PT diagram, there are PVT surface. Actually, all these four are the same. It depends on the way the engineer love to look at it. Okay, that's why if you look into the Einstein equation, Einstein loved to use symbol abnormal compared to other mathematicians. That's why to understand Einstein work, they must understand the Einstein kind of the use of the symbol for the equation inside the Einstein equation. It's such as the Bose-Einstein equation. There are a lot of equations. Okay. Other mathematicians, they love you. Say, let's say, for example, other mathematicians, pi is like this. But Einstein, no, they say pi like this. The symbol is different, and then mathematicians say, oh, they do get confused because when they say pi is like this, but the Einstein say pi is the other symbol. So they take time to understand, but as time goes by, now people can understand what Einstein trying to mention. Okay, so the uniqueness. So that's similar to the thermodynamics diagram. Okay, why the engineer love to see this the other ways around. Okay, some engineers they love TV diagram like me. Some engineers they say no, I want to look into the pressure first. Okay, like such as in our thermodynamics table, they have one side is temperature first, and then the other side is pressure first. So the B table is related to pressure first. So you got the pressure and then the temperature. But some engineers say, no, I love the temperature first, and then I want to know what is the temperature and the pressure. So that's why they have table A. And dekat thermodynamics table you all yang saya dah bagi. Okay. So hopefully you guys, kita boleh sebut guys, jadi girls cakap, kenapa sebut guys saja? What about us? We are the girls also. So you all ni kan macam sajak pula cakap, semua salah lah cakap. So nak cakap nak ganti kata ganti diri apa? So most of you must have the thermodynamic table printed next to you, okay, and then be ready when we're doing the tutorial and also the, later on in final exam and midterm exam. Okay, I don't know yet about the midterm exam. So if the midterm exam is only involved thermodynamics, then it's quite easy. If the midterm exam involve both thermodynamics and heat transfer, then it's going to be challenging to you all. Yeah. Even me myself, I'm very scared of heat transfer. Heat transfer means you transfer the heat from here to here. It's just like you transfer electricity from here to here. Okay. So like, yeah. But if you look into the compressed TV diagram, so these are the saturation line. So I have taught this last week. So these are the saturated liquid line, and then come to the critical point, and then after that, it's all this line after the critical point is known as saturated vapor line, or in Malay we call it hat tepu air. Hat tepu air, kind of awkward. And then saturated liquid line. Okay. Right? So this line are known as the pressure lines. Kita tukar sikit lah. These are the pressure line. So this represent pressure. Let's say pressure is 5 megapascal. Okay, so the below line should be, let's say 1 megapascal. This is a constant line. So tu lah okay pakai komputer. Right. Okay, but some engineer when they look into the table B, they start with the pressure first. So it's the same, but these are the same saturated liquid line and also the saturated vapor line. Okay, but The line here is temperature. Itu je beza. So the line here is temperature. So T 20 degree Celsius. Okay. Boleh nak tunjuk nanti dalam tutorial nanti ingatkan saya. So minggu depan ada tutorial the following in 2 weeks time. So I will show you how to draw the PV diagram. But don't take it seriously because I want you to guys to all of you to concentrate on TV diagram. Okay, so you be like myself. So I love TV diagram. So I love to see the diagram like this. Some people like to look like this. Saya juga lah kalau tengok kalau kata my angle of webcam is, you can see my right hand side of my face. But most of lecturer they love this kind of position, so they'll put the webcam straight forward 90 degrees. Macam orang kuno straight gitu. So mine is more like this. Biasalah Korea mana ada gambar macam ni. Korea semua ada gambar macam ni kan. So biasalah kita orang Korea. Right. And then we look into some, and then there is also temperature. Engineers say that we like to see this kind of PT diagram. Okay. So in PT diagram, we change it into a kind of 3D diagram. Okay. So these are the sublimation. These are the triple point. The triple point from here, you can see the triple point is like this. Okay. And then we have the melting, vaporization, and they're segregated between liquid and vapor and solid. Okay. And then some engineers say, no, I want all these three all together, P, V, and T together. So what you can do? They make it a 3D diagram. Yeah. So okay. So from here, there's a pressure here. So the pressure here now is on the z-axis, y-axis. So the volume on the x-axis, and the temperature on the z-axis. So volume on the x-axis. Okay. So in terms of looking like this, so now it's looking like this. If you are looking like that, bam, 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 right? So now you can see the sublimation, the more like a shape of mountain, and that describe the phases of the solid, the gas, the vapor. Okay. So that's how the engineer like to see this kind of figures. So depend on you. Yeah.
Semua material ke akan follow karakteristik TV, PV semua ni? Atau ada special material yang tak ikut?
Just water.
Just water.
Water is so special.
Yes, correct.
That's why sebelum ni kita tengok water is just water. Now the water become, kalau Australia they call it, the water becomes the water, just the water. Tapi kalau kampung saya dekat ni, kami tak pasal panggil water, kita panggil water. Kampung saya cacat sikit. Right. So the critical line. So there are points where above, if you look into the thermodynamics table, kalau you buka thermodynamics table, you look at the last part of the the pressure, so table B, I think. Okay, so last part of the table is what, 22.06. So that is the critical point. Okay, so from the table you tengok the maximum temperature is 22.06. So that is the critical point. Okay, so these are where above this critical point. Okay, so here is known as superheated region. So here is known as a compressed liquid region. Okay, so from there, when they have this kind of thing, so the engineer say, no, let's draw this one. So that's why they come up with this saturation line and followed by subsequent saturated vapor line. Okay, so ni nak cerita kat you all macam mana how the engineer create this kind of line. Okay, the one that you know, I think you have heard about the Nobel Prize winner. So Nobel Prize winner is somebody that produced something, that novelty that nobody ever see before. So for let's say for the example for like this kind of things. Okay, so nobody have ever seen water like this kind of water saturation line, have a distinguish between the saturated liquid and saturated line. So the engineer who developed this one got a Nobel Prize. Right? So that's why Nobel Prize. So if one, let's say you say, I want to look Dr. Zahir in a way that the other side of the thing. So you guys create new equation, new things of the way of looking at me, then you get a Nobel Prize. Right? You can name it as apa saja lah, Sharifah from Sharifah Outlook ke apa. Right? Okay. And then the PV diagram also the same. Okay. The only difference is, okay, kalau the only difference is this one. Okay. The line of temperature is here. Okay. But macam biasalah, don't look at the TV, just look at the TV. Lagi pun senang TV, television. TV apa? Puna vision, tak tahu lah apa lah. Okay, right. Okay, so you see this kind of annotation. So let's say they remove one piece of plate. So by removing one piece of plate, when let's say they want this in this figure, try to explain to you that when the process of heating is like when you heat something, it's like that you remove something on the top of a piston, imaginary piston. So okay, so when the more you heat, then you feel like the sand blocks or the liquid block is leaving the system. That's why the imaginary piston going up. So you go up and go up and go up, and the phase inside then change from a liquid, compressed liquid, change into the saturated liquid, change into the mixture, have half portion of liquids and half portion of steam, and then after that it's heated until when everything change into a steam, full steam or saturated vapor, and then you can still steam up upon heating up the water until it is further expansion until all this plate is no longer there. So that's become superheated. Okay. So that's how the engineer explained the process. They want, you know, that in engineering is different, what, and it's getting difficult because we want to explain everything in maths. Oh, itu masalah kita. That's why when you enter university, you feel that why is so difficult to understand this kind of thing? In nature, it's now you switch on the light and the light is coming here, there, and then the room feel weird. But if you look into how the Edison or the Tesla, they come out with this kind of AC DC ground, and then you learn, and then when you learn in the AC DC ground, and then later on coming on, you know, like new contribution, new theory, and how to differentiate this one, how to change it, and then come out with DC, super AC, KT, KC, semua all these things change to the equation kan. And sekali cakap is the basic things what? It's just a light. Punyalah banyak equation macam you all belajar electrical electronics, jangannya equation kalau campur semua buku tu saya rasa boleh berenang from here until Penang, daripada Sungai Melaka kan, berenang dia sampai Penang lah kan, because a lot of equation are put in your head. That's why it's hard to score in exam. Alamak, jangan hang lah sayang. Okay. And then PT diagram. So in close up, apa lah ini dia detail sangat, nanti you all to sangat faham dia. Okay, so but the melting point, triple point is the point where they have three phases: the vapor, the liquid, and also the solid. Okay. And if the sublimation point is the point where solid and vapor are in together. So in the PV diagram, it's called as mixture region, right? Okay, now remember that the property table. So if you can open up your property table, so have your property table in front of your table now. Although some of you are, alamak, I'm still sleeping. I'm still sleeping. I'm still on my bed. Oh, what can I do? Continue sleeping je lah, right? Final exam nak selesai. I guess a bit to Starbucks. So nasib baik you all tak face-to-face class. Kalau face-to-face class, after this class, most of you guys have to go to Starbucks to have a drink. Why? You see these girls, they are making what? The milk turn into a saturated pepper mixture. Right? So let's say when all the water become foam, that's probably in the state of saturated pepper. Right. Okay, so just to relax before we go into the details of the next chapter, next section. So because this stuff have something related to the thermodynamics. So okay, so let's say later on, if you go to Starbucks, don't get too scared to go to this kind of coffee shop because of the name kan. Ada sekarang student saya pernah ajar dia pergi Starbucks. So dia teman saya pergi ke hospital yang swasta kan. Saya tanya dia, so nak minum apa ni? Dia tengok kita. Tak apa, doktor orderkan the best untuk saya. Padahal dia tak tahu nak order apa. So it's all the coffee there are the same. Okay, they are made from the espresso. They compress the high. Because the coffee, in order to get a good coffee, is what? They steam the coffee at a very high temperature, then they come out with the black coffee. So the black coffee is known as the espresso. So when they put milk, okay, and form the milk, and they put foam up there, it's become latte. If the foam is more than if they have more foam, then it's become cappuccino. But the composition are same. Kan? Kalau macam kita thermodynamics, kita ada apa? Liquid, vapor dengan tadi apa? Apa tadi? Liquid, vapor dengan solid. So sama lah. Kan? Compressed liquid di bawah tu kan. So these are the things yang so kalau Americano tu apa? Americano is a kopi O. Nama dia macam sedap kan, kopi O kan. Tapi nama dia Americano. Americano tu kopi O lah kan. Okay, these are the things. Next time kalau you go to Starbucks, tak payah takut. This is the same thing. Kan, kita panggil kopi susu, dia pun panggil latte. Kan? Kopi susu with extra buih is cappuccino. Kan? Kalau mocha apa? Kalau mocha dia tambah coklat. Yang tadi kan kopi, susu, foam, tambah coklat. It's become mocha.
Neslo.
Neslo kan. So, nama mocha tu adalah Neslo lah. Apa kadang-kadang kita ni. Macam you all belajar thermodynamics lah, you all macam scared for no reason. It's just learning about water and gas. Kan? Apa takut sangat? Kan? Saya rasa budak electrical electronics score subjek saya lebih daripada budak mechanical. Mechanical ni dia sebab budak electrical electronic, you guys you can see. Sebab mechanical ni apa? Mechanical ni dia di antara nampak dengan tak nampak. Either in the state of you can see or you cannot see it. So in the middle. So jadi imaginary budak electrical is much higher because they don't see the electric, so they can imagine that the heat is like this, the change of the state are like this, so they are much more faster in learning thermodynamics. Okay, so now we look into the property diagram. So now dah tu semua dah buka lah. Property diagram, property table kan. Okay, now. So this is not as saturated water, so either table A or B. A is what? A1, A2 is... Saya ambil property table. Okay. So A1, A2 is what? So A1, A2 is temperature first. And B1, B2 is they have pressure. So the first line is pressure. Table A, the first line is temperature. So they are identical. Okay? Of course, when certain temperature, they have certain pressure. At certain pressure, they have certain temperature. Actually, it's the same graph or the same table. So if the question say that given that the temperature is at where the pressure is, so we look at the temperature. If the question say the pressure of the steam are compressed liquid, so you look at the pressure. So you have to look at the table B instead of table A. So let's say dia macam apa, you have two fried chicken, one from KFC, one from McDonald's. Both are spicy. So either you pick either one, it's still a fried chicken that tastes good. Right? So we have temperature. So for table A, we have pressure, temperature first. So next to the temperature is pressure. Okay. Next temperature is pressure. And then we have saturated liquid. So this one is small b, this one is small u, this one is small h. You guys don't learn yet h, but the specific entities, so how it's become superheated, compressed, and saturated liquid or mixture, they have the same property, they have the same characteristic as internal energy and volume. That's why in the example, although you guys didn't learn yet U and H, but you guys can solve anything. You can solve this kind of problem as well, because the characteristic of compressed, mixture, saturated liquid, saturated vapor, superheated, they're the same. Okay, right. Okay. So there is no VFG. So VFG stand for mixture region. So VG minus VF. Then some students say, why there is no VFG? Because there's not enough columns there. If they put VFG here, so that they have to decrease the font size, and it's not good. But there are some books that they show that VFG, VG, UFG, UG, HF, HFG, HG, SF, SFG, SG. So you guys didn't learn about the SF entropy. But the lab two have certain element of entropy, but that one is quite straightforward. So okay, right. Okay. So for the compressed liquid region, and then we have the saturated liquid vapor and until superheated vapor. This point, okay. So the table, and if is the volume of the compressed liquid, then it's approach to the volume of NEVF, UF, HF, and SF. If the volume is within a mixed region, so VFG, UFG, HFG, and SFG. If touching this point, okay, so it's a VG, UG, HG, and SG. Above this point, you have to refer to table C. A, B, and C. C1, C2, C3, C4. Okay? It's not the bomb hantar tuya tu kan, C4 kan. This is one is superheated. Tak ada kena-mengena dengan hantar tuya apa, tak ada kena-mengena. Right. Okay. Right. So you dah faham. Saturated liquid, nampak situ. Saturated vapor, nampak point. Then evaporation ataupun mixture region. There. Saya ulang sekali lagi. So saturated liquid, the green one. Saturated vapor, the blue one. Mixture region is the yellow one. So between the blue and the green is not actually area for mixture. Okay. Some books they call it saturated water vapor. So most of the book call it mixture. And there are some books say that mixture of saturated liquid water vapor. Ambil semua dia ambil. So you nak tu dia mana tu ambil lah. Asal you bahagia sudah. Kan? As long as you are happy, you can choose any word. For me, just mixture. And when we say mixture, so it's a mixture of liquid and vapor. Ataupun liquid and steam. Some book they call it vapor, some book they call it steam. Snobs, because water ni sometimes they don't like call it vapor, they call it steam. So the steam, kenapa hospital tu kenapa the steam? Some book they call it steam, some book they call it vapor. And then some book they call it superheated vapor, some book they call it superheated steam. Okay, so for final exam question, they say superheated steam. That means superheated vapor. Okay, right. So these are later on in the next chapter is about H. So H is U plus PV. Okay, this one you will guys will learn later when we come into the first law of thermodynamics. Okay, then we start using H. S don't need. We don't use S for electrical student. But in future, don't throw the thermodynamics book. If you work in the oil and gas industry, let's say you are anak Sarawak, then you have a chance to enter gas punya, sebab Sarawak dia banyak gas kan, gas region, dia punya banyak gas kat Bintulu. Dari Bintulu tu dia banyak gas, liquid gas compared to oil. So probably you guys, if you work in that particular area, you have to open back the thermodynamics books. And so open back the thermodynamics where you have to look into this chapter, but more related to ideal gas and PV equals to MRT. Tapi kalau you tak kerja tu, you jual insurans, tak ada pakai dah lah subjek ni, kan? Jangan cakap what we learn university is not going to use in real time punya real life punya industry. No, because you work in different kind of sector. And if you work into this particular section, then you akan pakai lah thermodynamics, kan? Macam saya learn aerospace engineering, balik pada Korea, belajar dalam macam Korea, balik-balik kerja kilang LG Electronics, I become a speaker tu buat apa? Speaker more electronic kan? Jadi pada aerospace tiba-tiba jadi electronic engineer, lari benda, lari lagi tak kenal kan. So that's life. So the most important thing that you learn in the university is what? Is the way you write the report, the way you present your ideas in front of lecturer to show that the assignment. So this our group present. That's the lifelong learning, the knowledge that you're going to use in future. To convince people. Let's say you jual insurance, tapi masa you learn engineering punya module, you make a good presentation. Then you become a insurance guy, then more people will buy from you because you'll be able to speak and to explain and to present and to convince people to buy insurance from you, right? That is what university gives you, the knowledge. We call it soft skill. The soft skill is something that you have to enjoy throughout the process of learning in university. Not just this theory. There we know in future when you go to kilang or factory in the morning and say, okay, enter at clock in at 8 o'clock, sit in your desk, okay, answer the quiz thermodynamics. Mana ada? Tak ada. Tak ada exam semua. All the real life application. So the knowledge that the soft skill that you learn, let's say how to use the Excel to plot data, and also now you plot data for let's say for experiment 1, it's Boyle's law, and that's that sort of things, characteristic or the things that how to plot data is how to use this in analysis. You plot data of control actually plus minus. There's always learn like your friend and your job you do it yourself, you do together. Otherwise, you lose soft skill and relationship in future. So this is we talk about the access. It's the one that is a lot of things. So you guys know you can have time to learn. It's a second law of okay. So then I have this so the one that's one F is identify F. Separate liquid. You know why F is because I in my mind is because it's F plus what fluid. You can see liquid. Because this is I. So that's why there is S. So F plus what is the liquid. Okay. And then G is what? Vapor. So why did you put GG? Is it GG is where people only the gas. So just why it's just so the vapor we use E as also GG. So you know now best one apa kajian dia SMG mungkin orang guys buat PhD apa ada orang SMG awal jam why so you can put one into the GCF dia punya like but people just SMG GM last time we asked the second part of the question. Please try to do the on the first part of the question. Okay, the first question. Okay. So if you can understand it from you can then probably when later on to do this time when explaining again, then you can appreciate. Okay. Right. That's another thing.
Saya nak tanya
Boleh saya.
yang ME dan mana
ME, math ni.
oh ni mana dia volume
Math ni yang equation adalah bila kita ada projection. So pokok math yang ada. Bila math kita ada definition lah banyak jalan-jalan itu banyak dulu. Betul. Kan. So tapi bila banyak X kita dah sudah MM cari kali untuk ini sesuatu yang boleh itu dia adalah dia tapi dia daripada nak dia punya paling asas yang basis betul ini semua nak yang daripada sisi banyak kita dapatkan kita sosial itu dia kelas energi kalau energi itu masalah energi itu dia sekarang energi sudah banyak X adalah kuasa dari energi kita bagi nilai dia dia bagi nilai M dan resesi masalah ada resesi dia macam kita kawan-kawan dia kawan-kawan dia ada dia F over T. Jadi F dia tak exercise sama dengan Y. Sebab dia tinggi ni keluar dari kita dengan yang adalah unit check. Unit check yang boleh kita pada semua ada exercise juga. Tapi unit check ada cases. Mereka cases you don't very close because the progresses my country. This is my country. If you want to know that they pop up a lot of Indian institute of technology. Go there, especially if you go to from IIT. And if you go to India, so I think brilliant manusia itu Indian institute of technology. Dia punya pasal China, pasal sebenarnya itu banyak. A lot of one state there so to I didn't China IT. So they about Korea so this was why the president is in this was what my success is dia I used to Caltech California Institute of Caltech specifically MASA kan lebih power kalau you orang pergi institute you don't have that dan itu semua university kalau NASA dia itu Petronas automatically dia call you sex kita jadi siapa kalau orang ada special school you attempt dia nak berebut masuk Petronas, dia nak lawan bukan apa sebab ramai orang pada you attempt nak masuk Petronas. Kalau duduk sekolah macam mungkin ada seorang rakyat Malaysia dia senang masuk. We look into different perspective angle and it's different way lah kan. Betul, power sekolah tu sebenarnya tak power sangat pun, tapi sebab dia special kan. And then the superheated water vapor region. So this one is the area where you have to refer to table C because they are superheated. They are leaving the area of the saturated vapor line. Okay, so they leave this area. So once they leave this area, they have a special table, which is table C, the superheated table. Right? Because the characteristic of water can go beyond and beyond that. Kan sekarang ni ada isu politik dia sell SUARA. SUARA ni dia company that use high silicon ni. Jadi dia banyak gunakan water untuk cooling dia punya machine, dia punya produk for fan, all this thing kan. So probably the way they control the water, they use what we have learned today. Tapi of course dia tak nampak lah benda-benda ni semua sebab semua sekarang dah digitalized. You guys masuk university, you learn the very fundamental. Bila you go to the advanced, you tak nampak dah benda-benda ni semua ni. You tak nampak, semua dah digitalized kan. Macam this I'm currently examining this PhD thesis from India. It's nuclear power plant. Nuclear power plant operator, lebih pada dia design coding system. Saya baca nak faham dia punya coding untuk nuclear power plant tu. So dia buat, bila dia buat benda ni baru nampaklah dia the one that we learn ni bila dia buat coding kan, rupanya dia pada basic fundamental theory yang kita belajar this thing. So I really wish when you guys are leaving UTM, so you guys work, don't leave the engineering area. Don't leave. Memanglah kita tak mau you all, kita tak boleh sekat you all punya kriteria, tapi if everybody leave the engineering sector, then who's going to work in engineering side? We know that the salary is still not, tak sama, tak berkembang lah. When I start my career as engineer in 2009, mobil 19 years ago, the salary is about 2,000 ringgit. But now, 20 years later, still 2,000 ringgit, you know. Unless you go work with Petronas, then you got 3,000 kan. That's why people, at that particular time, 2,000 ringgit zaman saya tu kira okay ya. Masa tu sewa rumah kat Melaka, bila saya start ajar UTM, the whole house is about 200 ringgit. Sekarang 200 ringgit dia dapat bilik kecil ni kan. Rental room rental is 200 ringgit. At that 20 years ago is about the whole house. So that's the thing. Satu lagi, bila bidang engineering you tak boleh go further up. So at certain level you have to enter management. That's why the soft skill that you learn in university, such as doing reports, such as presentation in class, that's the soft skill that you're going to use throughout your learning process. Okay, so kalau you ni sebab certain level, so let's say you become the maximum is what, director of engineering or R&D. So after that, you have to go to management. You nak jadi CEO apa semua, and that's involve management. So you must have the skill of managing people. So itulah benda yang you kena accept in plan. So you must be able love, you hate it or not, you have to love management. You must know the soft skill, how to manage people, how to manage yourself, bangun awal, datang kelas, and time is very short. Okay, ingatlah, time is very short. Okay, if the pressure is less than P saturated pressure, okay, then it's become characteristic for superheated region. So that's if the volume that from the question is larger than the volume of the G from the table, that is also superheated. If the internal energy is larger in the internal energy that given in the question is larger than the internal energy from the thermodynamics table A or B, then it become superheated. Then you have to temper to table C to get the answer for your question. Okay, fine. Okay, so let's say now you have determine the internal energy of water, 200 kilopascal, 300 degrees Celsius. So the first thing you have to do is what? 200 kilopascal, 300 degrees Celsius. So this, let's say this is 200 kilopascal. So P 200. Okay. So this is P equals to 200. Right? At 300 degrees Celsius. So what are the temperature here? 120, 120. So that's mean by reading from the alamak. So by reading from the table. Alamak. Okay. So by reading from the table, you can see that the line here is kita lukis ni kan, is 200 kilopascal. So the temperature is 223. So the saturated temperature throughout this line, whether it's saturated liquid, mixture, or saturated vapor, is 120.23. But the question says what? 300 degrees Celsius. So 300 degrees is above here. So 300 degrees Celsius. So it's a superheated region. Okay. So when we know that it's a superheated region, so the pressure is what? 200 kilopascal. So in 2 megapascal. Okay. So 300 degrees Celsius. So 300 degrees Celsius. The question answer to internal energy. So read it from table C at U. So the answer is what? 2808.8 kilojoule per kilogram. Okay, so very straightforward question. Itu bila kita tengok dalam tutorial is what? It's more like in a table form. This one is in terms of words. Okay, determine the internal energy of water at 200 and 300. But before the example that I showed on Tuesday night, this other table fill in the blank. So it's actually the same thing. They give you this one, but in terms of word, like this one they give you in terms of word. Because the final exam tak boleh lah buat table kosong tu, itu. Jadi budak je satu budak je satu lah pergi sekolah, isi tempat kosong. Kan? Takkan engineer isi tempat kosong, engineer have to interpret, and then put it in terms of table. Tableize it from the interpretation of the data, interpret the data given from the very long sentence, interpret into a structured form of tabulated table, and then from there you calculate what are the characteristics of this water at that particular problem. Barulah engineer sikit kan. Engineer, kita dah pergi berapa dah? 9 suku 9-11, okey awal lagi. Saya ingat dah pergi 10 tadi. Okay, baik. Right. And then we look into the second part of question. 0.52890. Instead of giving you pressure and temperature, now they challenge you, I give you pressure, I give you 2890, the H, the enthalpy. Assume that you guys already know what is H. So at 0.5 megapascal, ataupun nanti dalam exam kita bagi 500 kilopascal. So 500 kilopascal is 0.5 megapascal. That is the main. Sometimes you fail the exam. If not fail the exam, fail that particular question is because you didn't convert it. You assume that 500 kilopascal is what? 5 megapascal. No, 500 kilopascal is 0.5 megapascal. So 0.5 megapascal. Look at this idea. Because the question gives you determine the pressure at pressure. So because it's pressure, so look at table B. So 0.5. Okay, so if draw the TV diagram, then you got ni kan, apa you can dapat draw TV diagram, you can dapat. Okay, 2748. Okay, senang je. So kita draw TV diagram. Alai. Alamak. These are the TB. Draw the saturated liquid line, critical point. Okay, and then tukar color sikit. Okay. Ambil ni. Okay. Cantik. First time. Jaya okay. Then 0.5 megapascal. So these are apa? Alah? Tak tidak okay balik. Macam mana? Alah, macam mana okay? Alah. Ni. Tadi si Luki macam mana? Stres aku. Susah. Baru nak belagak. Oh, pakai yang tu. Alamak. Aduh, taklah sekolah punya. Apa profesor? Yang ni tak terlukis. Apa hal? Okay, and then slide. Okay. Alah, dia ambil keadaan ni pula. Time saya ajar pakai ni. Alamak, tak cantik. Patut ni straight line lah. Susah tu lah. Okay, tak apalah. Awak assume je lah. Okay. So, 0.5. So, P equals to 0.5. Alah, susahnya. Ni semua 0.5. Ni patutnya straight right? Megapascal. So it's what? So saturated liquid kalau kat sini maksudnya kalau sini T, sini kira H lah kan. So, kalau bacaan kat sini apa? H dia 640 640.23. So dekat sini 274, alamak, 2748. Question give what? 2890. So lebih besar. Is here lah 2890 kan. So dia akan jadi apa? Yes, dia akan jadi dekat sini, alamak. Dia akan jadi sini lah. Mixture kan? Mixture. Ha.
Macam mana nak tahu tengok HG instead of HF, HFG?
Saya tunjuk saya pakai saya punya ni.
Boleh.
Saya pakai saya punya kamera. Daripada you tengok muka saya pun you tak suka saya.
Mungkin.
Saya suka tengok muka saya.
Tak suka tengok saya? Tak suka tengok saya.
Suka.
Okay. So this is T. Itu kita pakai soalan itu is more like V. Sekarang ni kita H lah. Soalan ni H. Okay. Oh, now so these are standard line lah. So now pressure 0.5. So we know that pressure equals to 0.5. Nampak saya punya kamera? Okay. 0.5. So dekat 0.5, if you look at the table, it's what they give you 640 point. So sini F kan? F ni saturated liquid lah. So saturated liquid, if HF, kalau sini V, kalau soalan ni bagi V, then this is V lah. So V, kita baca lah. HF 640.23 tak salah saya lah. Saya tak nampak situ. 2748.7. So this one is from the table. Okay. You nampak? So this is very clear. Right. So what happened next one? The question say P equals to 0.5 megapascal at H equals to 2890. Ni from the question. So 2890 is what? Lebih besar. So 2890 kalau dekat sini, kalau kata 2600 dia ubah soalan. Then it's become mixture. This one is become 2890. So 2890. So here. So bila here 2890. So dia adalah keadaan state of superheated agent ataupun superheated vapor. So dia become superheated vapor. Dan kita tengok table C. So that's why kalau you tengok dekat bawah tu kita pakai table C. So at 0.5. So 200 is what? Bacalah H dah. 28. Apa ni? Tak ada. Alamak. Tak ada. Kan? Tak ada kan? So yang ada adalah di antara 200 dengan 250. So, okay. So yang kita ada 200 degree Celsius. Dia punya bacaan H dia 2855.4. And then 250. 2960.7. So H temperature yang dicari from the question dia nak isi this one lah sebab dia nak di antara T at 200 to 890. So yang ni kita kena buat interpolation. Okay, so yang ni tolak yang ni. So this is a very interpolation. Bahagi yang ni tolak ni. Sama dengan this one tolak this one. Bahagi this one tolak this one. Okay, so T minus 200, 250 minus 200, equivalent to 2890 minus 2855.4, 2960.7 minus 2855.4. So you dapat T equivalent to 216.3 degree Celsius. So that is the answer for present work. Yang ni kita panggil process of interpolation. If you look into my YouTube channel, if you look into example of tutorial 1B tu, there will be some example that you need to conduct some interpolation. Although it's just a table kan. Sama saja. This one is in term of word. Determine the temperature of water 0.5 H2NO0. Tapi kalau yang tutorial tu, dia bagi T, P, dia bagi H, lepas tu dia bagi kosong yang lain. Jadi, interpretation dia sama. Find T, P 0.5, H is 2890, Y is X, X tak adalah. And then, what is phase? Phase is superheated vapor. So the same point. So kita kadang-kadang daripada bentuk ayat, we can translate it into form of tabulated table. Okay, very clear. Tak apa, hari ni tak clear lagi lah. Kadang-kadang very clear. So kami tak clear tapi kami takut nak cakap. Yalah, baru belajar hari ni, takkan nak pandai terus. So so it take times to learn. Okay, so far faham boleh okay. Kalau boleh, itulah sahaja. And then, so they use interpolation. Okay, so interpolation. So macam mana nak solve interpolation? Saya show kat you. Right. Dulu saya baru tak confident juga nak ajar pakai WebEx ni. Bila dah lama-lama ni dah okey sikit lah. Dah fikir macam mana aku nak ajar interpolation pakai WebEx. And then the compressed liquid reagent. So compressed liquid reagent is very simple. Bukanlah very simple. Okay. So very simple. Maksudnya dia tidak ada bacaan sebab dia tak ada value kat sini. So the value yang kalau kita kata state of compressed liquid, then kalau kata value dekat sini, dan baca dia adalah kalau volume menghampiri bacaan VF. Dia bukan V sama dengan VF. V sama dengan VF hanya dekat sini. V equals to V approaching the value of VF. So almost the same value of VF. Okay, so sama dengan macam H sama approaching the value of HF for compressed liquid. Okay, right? Whether it's H, U, Y, lah. H, U, V, U, V, H, V, U, H. Sama lah. Okay. Right. So if the pressure is larger than P saturated, then it's become at given T, or T is less than T saturated at given P. Okay. Macam mana nak faham T less than T saturated? Macam tutorial hari tu. Right? So kalau kata kita ada soalan compressed liquid macam mana? So katalah P T equals to 80 degrees Celsius. Next question. Okay. So determine the internal energy U at compressed liquid at 80 degrees Celsius. So automatically you can read from the table. So U 80 degrees Celsius is UF, approaching UF. Okay, so you can baca terus daripada UF. Okay, right. So you boleh baca straight forward. Kalau 5 megapascal, so kalau 5 megapascal, table terabur. Gigi kau berterabur. 5 megapascal. Alamak, tak ada. Alamak, mana 5 megapascal? Hilang lah. Tak apalah. Oh. So, how to compress liquid? So kalau 5 megapascal, that means HF dia apa? So, bacaan dia kalau dekat 5 megapascal, so HF, jawapan H adalah menghampiri jawapan HF, which is 1154.23. Okay? So, dia menghampiri bacaan HF.
Prof.
Menghampiri.
Prof, bukannya nak internal energy.
Oh, nak internal energy lah. U, okay. U. Nak internal energy bagi U. UF. So, 1147. Okay. U sama approaching the value of UF. 1147.81. Tentu je lah soalan, nanti dia ubah. Kalau sekarang saya tanya dia dalam bentuk example apa? H dengan V. Nanti exam keluar U. Itu je. But the volume, the characteristic are the same. Kan? Okay. So tak payahlah takut. Dia senang je. Kalau midterm, kalau kata quiz apa? Quiz A plus B equals to C. Tapi kalau midterm, A plus something equal to C, what are the something? What are the B? Tapi kalau final, so I give you C, I give you B, what is A? Macam tu je lah. Selagi B ya. That's why, masa saya belajar dulu, I really love exam. I can express my feelings toward the exam. What I have learned throughout the semester. You guys kalau exam takut, jangan takut. Just luahkan perasaan you dalam exam. Kalau tak tahu jawab tulis, right. Okay.
Dapat markah lah tulis macam tu.
Tu lain tak dapat aja. Right. Okay, so saya rasa takat tu saja lah kot. Ideal case nanti kita akan, ideal case is much more straightforward. Okay, ideal case is very simple to understand. Instead of, if the question start with hydrogen, oxygen, then jangan tengok table. So just use PV equals to MRT. Sebab bila dia change state, then it becomes state 1 equals to state 2. V2 per T2. Kan? Ataupun P1, V1 equals to P2, V2. So these are the ideal case. Ideal case is much more easier to solve the problem. Tak payah tengok table, but you can guess this one. Kalau nak calculate H, nanti mungkin kita pakai M, CP, delta T untuk dapatkan nilai heat. Okay, tapi kalau kata bila sistem yang thermodynamic biasa, kita kena find T ni from table. Okay, kalau kata heat transfer apa ni, for ideal gas, we can just simply use the direct from soalan tu. Kan? Nanti you akan tengok nanti, you will, I will teach you guys later on this kind of things. But for ideal gas, it's very straightforward. It's either P1, B1, P2, B2, P2, V1, B1, T1 over P2, P2, T2. Okay, so this one. But the basic is coming from PV equals to MRT. Right? Kalau macam, kenapa sini ada PV? Kenapa ada kadang this one? Senang je. M is what? M is mass. So, sebab kita belajar intensif dengan extensive. So, the one is different on, kalau small is what? Specific. Specific volume. So, specific is what? Meter cube per kilogram. That's why dia tak ada kat sini. This one is large volume. Sebab V equals to M small v. That's why PV equals to MRT. Okay, so sebab kita belajar dalam thermodynamics, dia ada intensive dengan extensive. This one is extensive, this one is intensive. This both are extensive lah. Okay. Sebab extensive lah yang menyebabkan mass ni boleh jadi one B besar ni boleh jadi V kecil. Right? Small v and large v. Right? So can water become an ideal gas? Yes, for certain area when it's too hot. Okay, when the water is too hot, superheated, then it might become ideal gas. But the water is very special. And why so special water? They can make a kowe and cuku. Imagine that. Just service water, they can make apa? They can sell machine and people like me pay 90 ringgit per month for the service. Orang kata apa? Napis air harga Yahudi kan? Right. So that's from water as well. So God create water for a lot of use. Kalau you pergi Australia, you see all the state or all the capital state or like Western Australia, Perth ke Melbourne ke Adelaide, and then Sydney, all are close to the shore and have a river there. And close to the river. Why? Because they need water. That's why we have learned in geography when we are in middle school, high school. Saya ambil SPM geography. Walaupun saya belajar pure science kan, tapi still take one extra subject, geography. Why? Because they force me to take that subject. Kalau aku tahu boleh lawan, aku lawan. Right? So that's it for today. Ini tak payah. Okay? So, hopefully, any question before calling your name? Susok terus. Tak ada, saya panggil nama je lah. Adrian. Adrian tak ada. Tidur lah, mati. Itu ada, Adrian ada. Dekat partisipan ada. Bila panggil tak jawab.
Dia pergi tandas ke?
Oh, dia pergi
Dia pergi
tandas.
tandas ke?
Ya ke? Akmal. Ada? Kau saya kena COVID lah, tak boleh cakap. Ashraf Farhan.
Saya.
Warla.
Azizi Aiman.
Saya.
And dia tu tidur lah. Dia on, tu tidur. Azizi